All right, here we go. We're going to do a quick video on chapter 3.5, the binomial theorem. All right, so let's talk about the binomial theorem. Binomial expansion is what we've been talking about recently, where we use Pascal's triangle. We've done a lot of different things here recently to figure out how we can take some binomial and expand it. And we've done the leading coefficients of each of the terms with Pascal's triangle, and we've had to do some other manipulation there. But now maybe we want to find some specific terms or specific values, so we need a new tool, and that's where the binomial theorem comes in. It says that any x plus y to the nth power is equal to the sum, remember the sum symbol, of to some nth upper bound, where I starts out at the 0th term, and we multiply that by we have that sum is given by n choose I, which is the nth term, and the ith term. We'll talk about that in a second. But then it's multiplied by x to the n minus I, where n is the total number of powers, or the power of the binomial. And I is the term that we might be looking for, or some value that we're looking for. And that is multiplied by y to the ith power. Okay, so this is our general format. And in your calculator, we've gotten used to n choose r, but it's the same idea, n choose I. And in the calculator, it's under your combination probability section. So same thing that we've been doing before. If you're unfamiliar with that, check out your calculator and go to Math and PRB, and then you'll find n choose r there with that. So n is the power of the binomial that we're choosing to encounter. And let's just review a quick history about, or a quick idea about the Pascal's triangle. Remember, it adds from row to row. 1 and plus 2 is 3, and 2 plus 1 is 3, and it keeps going. Now, this is where n is equal to 0. This is where n is equal to 1. N is equal to 2. And you start to notice that once this takes place, that first term or the last term will carry that same coefficient as your value of your row. Okay? Now, just to be clear, this is the 0th term. This is n choose 0. So this would be the first term. Technically not the first term, but when we're going to use the binomial theorem, these are the values 0, 1, 2, 3. So second and third in this order. So n choose 1, n choose 2, n choose 3. If you use n choose 1 over here, it's going to get a little sticky. So what we always want to think of is n plus 1 is the total number of terms given. So we might think that this is a binomial where it's the n value is 3, but look, it has 4 terms to it. All right, let's look at an example. We are given the question, example 1, find the term containing a cubed in the expansion 2a minus 3b to the 9th power. So let's see, what do we have here so far? We have that n minus I is equal to 3. Well, how do we know that? Well, that's from our expansion here, n minus I. We want that x value to be 3. So we set n minus I equal to 3. Now we know that n is 9. Okay, it tells us right here in the equation they gave us, n is 9. And so 9 minus I is 3, so we end up getting I is equal to 6. Well, now we're ready to set it up. And so we'll have 9 normally starts at 0, but we're going to 9. We're looking for a specific term now. So 9 choose 6. And then 2a, which is your x value, 2a is the x value, times negative 3b. Again, that b, that little line through that b just signifies that it's b and not a 6. Okay, we don't want to call it negative 36. and to the sixth power. So this was to the third power, that n minus I. We want 3 there, so we put that. And then that I value is 6, and we get that again from the y up here of the ith power. Now, if you do 9 choose 6 in your calculator, you're going to get 84. 2 cubed is 8, and a cubed is a cubed. And negative 3 to the 6th power is a positive 729, b to the 6th. And this is the value of the term that contains a cubed. Quite a large number, 489,888, a cubed, b to the 6th. All right, so here we go. Second example. It says, find the term independent of x in the expression 4x cubed minus 2 over x squared, all raised to the 5th power. All right, so what does that mean, independent of x? Basically means that we do not want no variable x. So we're looking for where x, the power of x, is equal to 0. So let's lay out what we have so far. We've got 5 to the ith power. We know that n is 5. We pulled that from there. We know our a or our x values are here, 4x cubed, 5 minus I. We don't know I yet. And then what we did here was we took this 2, and it's minus 2, right? We took the negative there, to x. Now what I did was make that x a negative 2 power, because it'll make it easier to work with, you see, when we go solve the problems. So we want all the exponents of x to equal 0. So what do? We put them together, we add them. So we get 3 times the quantity, right? There's the 3, times that quantity, 5 minus I. 5 minus I. And then there's negative 2, right? There's the negative 2I. And we use the power rule, and that's what allows us to multiply these exponents together. So we use that power rule, minus 2I equals 0. We distribute the 3, we get 15 minus 3I minus 2I equals 0. 15 minus 5I is equal to 0. And we end up getting I is equal to 3. We put I in as 3 back in. Here's the 3. We put that there. There's 5, 3. Times 4x cubed. And 5 minus 3 is 2. Okay, 5 minus 3 is 2. Negative 2x to the negative 2 to the ith power, which is 3, so cubed. And then we can simply solve this. 5 choose 3 is 10. 4 to the second power is 16. X to the sixth, again, power over power as we multiply. Negative 8 to the sixth power is going to be a number where once we multiply all these together, and again, here's x to the sixth times another x with a minus 6. That way our x will equal 0, and your final result coefficient will be negative 1,280. All right? All right, go back through that, review it a little bit more, and we'll talk to you soon. Have a great night.